through some Hawks problems here on the left here. Okay, so a combination you could pick for this problem would be like pizza restaurant, romantic comedy, so P, R, and then C for grabbing coffee. That would be one possible combination. And they want you to list all possible combinations. So I've worked a problem like this, and really the thing that you may recall is that the trick to it is just staying organized and making sure that you get every combination. Does anyone remember how you can find out how many, like how really quickly we can find out how many combinations there should be? So all we have to do to find out how many combinations there should be total is take the product of the number of each type. So I should expect 24 different combinations, and that's going to be helpful when I'm writing them all out. And there was a certain structure to the way that you list them out, and I'm not going to list them all out here, but we see that they are. So first they pin down the P and the R, so they've got PRC, PRI, and then they pin down the PA, so PAC, PAI, and then the PD, so PDC, PDI, and then PF, PFC, PFI. And now they're done with P, right? That was all the P combinations here. So now they're going to move on to B, and these next 8 are going to look exactly the same as the previous 8, except the P's been replaced by B. And then similarly, the last 8, the first letter is an S instead of a P or a B. So that's like a good way to organize your list. Instead of just trying to like poke around randomly to find all of them. If you just start writing down random combinations, that's not good. That's not a good method. You're almost definitely going to miss one. Okay, or accidentally write one twice. So if there are no questions about this one, I will move on to the second one here. So it says a data form asks for applicants' birth dates in the form month, day, year. Find the probability that the number made up of the first 2 digits on the form, so these digits, the month digits, the first 2 digits on the form is greater than 12. So the way you would do that is if you're finding a probability, then you need the 2 numbers, right? You need the sample space, the denominator, which is going to be the total number of ways that the total number of combinations you can get from adding up the first 2 digits on this form. So you could have like January being 01 and then February 02, right? Et cetera, et cetera. So that would be your sample space. But we'll see, it doesn't really matter in this case, because if you think about how many ways are there to get a number right here that is greater than 12, well, 12 is the biggest month, right? 12 referring to December, right? And we don't have a 13th month. We just start back over at 1, right? So having the first 2 digits on the form being greater than 12 does not make any sense. So that's why the probability is 0. So with cases like this, you can still write down all of the probability calculation. You can find the size of the sample space, which would be 12, right? And then you can find the size of that numerator, the event space, which would be 0, and 0 over 12 is equal to 0. So you would still get there if you decided to do it like more a traditional route. But the trick to this one is, I suppose, if you like to do it efficiently, is to think of the event space first. I'm sorry, give me 1 second. What are you doing, cat? Sorry, my girlfriend's cat has decided to be a nightmare this morning. Okay. So let me see how many more there are in here. Okay. All right. Let me see. I'm gonna do this one. This one looks more complicated than the others. It says Jesse has 247 songs on a playlist. He's categorized them in the following manner, and then he has categories for his music. All right. If Jesse begins listening to his playlist on shuffle, what is the probability that the first song played is a pop song? Okay. Well, we know the size of our sample space already because they told us. They didn't have to. We could have found it by adding up all these numbers, but they were nice and they went ahead and told us the total number of songs on his playlist. If we want the probability that the first song played is a pop song, all we have to do is take the number of pop songs over the total number of songs. And that's exactly what they did here. Now, when you're plugging in your answer, right? So I'm assuming we could all get this, right? So then what about plugging in the answer? Well, it says express your answer as a fraction in lowest terms. So how do I know if 27 over 247 is in lowest terms? Well, that's a good question, and you need different techniques for that. But for one, I know that 27 is just built from a bunch of threes, right? 27 is just 3 times 3 times 3. So does 3 go into 247? And you could divide it in your calculator and find out, no, it doesn't. So this fraction is indeed all the way simplified. But if you're not sure, then you can just pop this into the calculator, 27 divided by 247, and you'll get a decimal approximation from your calculator, and you'll round that to the nearest millionth. In other words, out 6 digits past the decimal point. Okay. All right. Let's see. We could do this one. What is the probability that a card drawn randomly from a standard deck of 52 cards is a red queen? Okay, so sample space is 52. That should be the denominator of our fraction. And then how many red queens are there? Well, we know there are 4 queens altogether, and 2 of them are red, so there are 2 red queens. So our probability is 2 over 52, which simplifies to 1 over 26. Again, you could just divide 2 divided by 52 in the calculator and get a decimal approximation if you don't want to deal with the fractions. Okay, so are there any questions about these so far? They're kind of the same flavor here. Let me know if you want me to actually write any of these out. Oops, if you want me to write any of these out. Okay, all right. This one is, hang on. Okay. This one is, what are we doing here? We're flipping coins. We're flipping 9 coins. So the trick to this one is finding the size of that sample space there. So if I know that flipping a coin 1 time gives me 2 options, and then flipping 9 coins, then how many options would that give me? Well, we're going to use the same technique that we used in this problem right here, the date night problem, where you take the product of all the different possibilities. So what I mean by that is there are 9 2s, right? So we're going to take 2 times 2 times 2 times 2 times 2 9 times. So in other words, 2 to the exponent of 9, right? 2 to the power of 9. And you'll see that that gives you 512. That'll be your sample space. So when you're doing an experiment, or rather solving a probability problem where you're flipping coins and you want to know that sample space, you just take 2, the number 2, because that's the 2 options for flipping a coin, heads or tails, and you raise it to the number of times that you're flipping the coin. So if you go to your calculator and hit 2 to the 9th, 2 raised to the 9th, which on your calculator, will look, you'll have different buttons to do that. You'll get 512. Now they say find the probability of obtaining exactly 9 heads. Well, how many ways are there going to be to get 9 heads when flipping 9 coins? There's only going to be one way, right? There's not multiple ways to get 9 heads. Every single coin has to land on heads. So there's only one way to make that happen. So that's why our probability fraction is 1 over 512, which any fraction with a 1 in the numerator is completely simplified. So you can feel safe plugging this in as the answer. Don't worry about, oh, is this simplified? You know, like back here, the 2 over 52 wasn't simplified. So maybe you're worried about that. But here, anything with a 1 where your probability is just 1 over the sample space, that's definitely simplified all the way. So you can feel confident putting this in as your answer instead of having to rely on the decimal approximation. All right, so I want to go to 7.2 now. Okay, so this is just a straight up arithmetic calculation. As long as you know those formulas for combinations and permutations, then this should be no problem. Which I might come back and work that one out. We'll see. All right. Oh, similar one. Okay. All right. So the first 3 questions are just evaluations. Like literally there's a button in your calculator for it. In fact, there's buttons in your calculator for all of these things. So you could ask your calculator what 4C3 is, and then ask it what 4P3 is, this combination, this permutation, and then just write each of those down on your paper. You'll find that this one is, can I do it in my head? Nope. Well, whatever it is, the fraction ends up simplifying to 1 over 6. All right. Okay, now word problems. There are 24 students in a high school senior class. In how many ways could the yearbook choose the winners of most athletic, class clown, and best school spirit? All right, so we're choosing 3 from a group of 24, but are the positions ranked or not? And you would think about it for a second and then say, oh, they are ranked or they are ordered, right? Because these 3 positions have different like names, right? It's like first, second, third. Well, it's not, they're not like first, second, third, but they have, the point is they're all unique, right? So having Sally, Jim, and Bob, that combination is different from Bob, Sally, Jim, right? The order matters. So we're going to use a permutation. So you would type in 24P3 into the calculator. Where am I getting the 3 from? Well, there are 3 categories here. So in order to solve this, we would need the permutation formula, which again, if you've got a scientific calculator, it'll do it for you. You just gotta, if you're not sure how to do it on your calculator, just type it into Google, you know, just type the name of your calculator and then permutation, and there'll be a YouTube video to show you how to do it. Okay, any questions so far? I want to make sure we're all good. Okay. 8 elementary classes will be chosen to participate in a lunch school survey. There are 23 elementary classes in the school. In how many ways can classes be chosen? So the greater group is the 23, and then we're choosing 8. We have to decide, does the order in which the 8 are chosen, does it matter? Well, they've given us no information to imply that it matters. So I don't think it does, right? There's just 8 classes that are being chosen, right? There's not first, second, third, fourth, fifth, sixth, seventh, and eighth position or anything like that. It's just 8 being chosen. So we would not use a permutation. We would use a combination here. So if I got my calculator with, well, let's see. I can't do it on the one on the computer. 23 factorial, which is a giant number, and then divided by, I know you can't see this, but I'm just confirming the answer, and divided by, yep, okay, I just wanted to make sure I got the same answer they did. So 23C8 is what we would use for that one. All right, a mother duck lines her 12 ducklings up behind her. And how many ways can the ducklings line up? So this one is not a permutation or a combination necessarily. This is one of the problems where you'd want to draw out a little diagram, like the little horizontal line diagram, like 12 little lines representing each little duck. And in the first position, there are 12 possibilities because there are 12 ducks. And then in the second position, there are now 11 possibilities because one of the ducks has been used up in position 1. And then in the next position, there are 10 ducks because 2 of the ducks have been used up in positions 1 and 2, etc., all the way down to 1. In other words, to solve this, you would do 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 479,001,600. All right, now this one says a college's lacrosse team will play 18 games next spring. Each game can result in one of 2 outcomes, a win or a loss. So this is like a coin flip thing. There are 2 outcomes for each event, a win or a loss. Find the total number of outcomes for the season record. So what you would do, for some reason it says the question twice. I'm not sure what that's about. What you would do is you would write a string of 18 little horizontal lines, but in every single one of them, there's just 2 possibilities, a win or a loss. So it's going to be 2 times 2 times 2 times 2 times 2, 18 times. And if you take 2 raised to the 18th, you'll get 262,144. Okay, so that's 7.2. I didn't do these first 3 because they're just arithmetic calculations. As long as you can either knowing the formulas and being able to simplify fractions, or just knowing how to do it on your calculator, that's probably the easiest thing to do, is just know how to punch these in on your calculator. All right, let's look at 7.3 now. Okay, again, just looking at the right side here. All right, how many are there here? 5, okay. Okay, Logan, John, and Charles and Tommy have a jelly bean collection. Together they have 35 flavors. If they decide to randomly choose 4, okay, so we're picking 4 from a group of 35. What is the probability that the 4 they will choose will consist of their favorite flavors? We must assume that their flavors are different. Their favorites are different. Okay, so how do we do this one? Let's see. Hang on. Did I do something? Okay. Okay, so we've got a group of 35 and we're choosing 4. Definitely going to be a 1 on the top because we want the combination where they get all of their favorites. So there's only one way that can happen because there's 4 of them and they're picking 4. So there's only one way that can happen, but of course we got to figure out how to get this, how to get the denominator of our probability fraction. In other words, the size of the sample space. Okay, so let's see. Let me get my calculator. Doing this on the calculator on the computer is a nightmare. Okay. What is the probability Okay, right. So does order matter here? Does order matter in this problem? Well, no, because, if they pick Tommy's favorite first, that doesn't matter. It's if we just want their four favorites, right? Um, and yeah, the order that they choose these does not matter at all. The jelly beans are not ranked, right? In like first, second, third, fourth, right? So we're going to use a combination 35C4. So you would plug that into the calculator, which let me show you again. I'm going to show you on my calculator in case a lot of you probably have the same calculator as me because, well, I don't know. I think this kind is good because of how cheap it is, and cheap and useful. So let me make sure you can see this. There we go. So if I want to do 35C4, I would type, oh, here we go, 35, and then I would hit this PRB button, which is like, actually, I don't know what it stands for. I always thought it might be probability, but I don't know if that makes sense. Oh, God, I'm trying not to get the glare. I know. I'll turn this off. There we go. So now we have 35, and then it says NPR, NCR, or factorial. So it'll do all of these things for you. I need to use the combination formula, and then I type my 4. So those are the two numbers that I'm using, 35, and then it says NCR 4. And I'll hit equals, and there it is. It does it for me. I mean, how nice is that? So what you need to do is go, if you don't have a calculator like this, go Google the name of your calculator, which would be like TI 30X, blah, 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 whatever it might be. It'll be written on the calculator somewhere. And then type, so the name of your calculator and then permutations. And Google or YouTube will show you how to do it. All right. Let's go back here. Now, these are misleadingly easy because, and I'm talking about number 2 here, because all you have to do is literally count up the letters, like whatever it's asking you to do. You don't need permutation, you don't need combinations, you don't need factorials, nothing like that. It says find the probability of choosing a letter other than E from a bag that contains 18 letters of the name William Shakespeare. So they already told us there's a total of 18, so we don't even have to count up the total. How many letters are there that are not E? That's what we need, right? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my fraction is 15 over total of 18. And that's exactly what this is, right? 15 over 18. Pull a 3 out of both of the numbers and you get a 5 over 6. But again, if you didn't want to deal with simplifying the fraction, then just go pop 15 divided by 18 into the calculator and then round appropriately at the millionth position. In other words, 6 digits past the decimal point. Okay, I think I've already worked a couple of these, but let's see, maybe not. So blah, 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 blah. Let's see. A pizza parlor is running a special to encourage patrons to try new combinations of toppings. They list all possible 3-topping pizzas, so 3 distinct toppings, telling us that they don't repeat toppings, on individual cards and give away a free pizza every hour to a lucky winner. So they're taking, like, one card might say, pepperoni, sausage, tomatoes, and they give that card away to someone and they get that pizza for free. All right, find the probability that the first winner who's randomly selected, or rather the first winner randomly selects the card for the pizza topped with, and then they give us one specific combination, beef, pepperoni, tomatoes. Well, so our probability fraction is going to have a 1 in the numerator because there's only one possible way for you to get this combination, right? There's only one possible way. because there are 3 choices and all 3 choices have been selected for you right here. So our probability numerator, yes, will be a 1. But what about that denominator? How do we find how many different possible ways are there to pick 3 pizza toppings from this list? Well, we count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. And we want to pick 3 from the group. And does order matter? No, order does not matter, right? Order does not matter for pizza toppings. So we'll do 20 and then NCR and then 3. And we'll get 1,140, which fingers crossed is what the answer was. And it is. Okay. Well, it's not the complete answer. What I mean is it's the denominator of the answer. It's the size of the sample space. Okay. So how do you know when to use just straight up normal counting methods, like literally counting things, as opposed to combination versus permutation? Combinations and permutations are for when you're picking things from a group like this, choosing 3 things from a group of 20, for instance. And in this problem, you could still actually do it that way. There is a way to for sure to force a combination formula into this problem, the William Shakespeare one, but it's definitely not necessary, right? When you can count on your pretty much like your fingers and toes the different number of combinations, then you don't need permutations and combinations, right? You need permutations and combinations when the numbers are massive, like the like this one, 1,000. You know, how are you gonna count all of the combination? I mean, give me a break, right? You couldn't even list all these on a piece of paper. It's just too much. That's why we use permutations and combinations when the numbers are a lot bigger. Why does my laptop keep? All right, there we go. All right, another similar one. I think the rest are similar. So now it's 10:30. I want to give you guys a chance to ask me any questions about any specific ones that you'd like for me to write out. So yes, Yusuf, go ahead.
I just had a question on the last example we did. So when we counted them, they were 20, but how did they round it up to be 1,140?
Okay, so let's see, is my screen back on? Okay, yeah. So there are 20 total items. Let me turn this light back on so y'all can see a bit better. 20 total items, and we want to find the number of ways there are to choose 3 items from the group. So that's like the question that you're asking. Well, not that you're asking. It's the question that you should be asking for finding the size of the sample space. In other words, finding the denominator of the probability. So there are 20 total items, and we want to find the number of ways there are to choose 3 items from that group of 20. And this is going to go into the denominator of our probability fraction. Well, we know that the order does not matter. So when you've reached this conclusion that you should do this, that you should answer this question, next thing is to say, is it a permutation or a combination? And in order to answer that, you say, does order matter or does order not matter? Since we know order doesn't matter because we're talking about pizza toppings, and the order of pizza toppings is not relevant. They're not ranked, right? So we use a combination, or I'll say it this way: use the combination formula, which, by the way, is use the combination formula, which is NCR is equal to n factorial over r factorial times n minus r factorial. So I'm going to have 20 and 3 plugged in for n and r. So I'll have 20C3. I'm going to do it by hand, but recall that we can, if you figure out how to do it on your calculator, then you can rely on the calculator to do this part for you. But I'll do it by hand, just for fun. So 20 factorial over 3 factorial times 20 minus 3 factorial. That's giving me 20 factorial over 3 factorial times 17 factorial. 20 minus 3 is 17, sticking that factorial on the 17. And then I recall this trick where I'm canceling. I know that 20 factorial is all of the numbers less than 20, all stuck together by multiplication, right? 20 times 19 times 18 times 17 times 16. And I know that 17 factorial is very similar, except it starts at 17. So I'm just thinking about what's left over. If all of the 17 and below can cancel out, then I'm left with 20 times 19 times 18. So that's the 20 factorial over 17 factorial, leaving me with these three numbers all stuck together via the product up there. And then 3 factorial in the bottom is 3 times 2 times 1, which of course is just 6. And then at this point, I'm just going to go ahead and ask the calculator to do this last step. So I'll do 20 times 19 times 18. I could simplify a little bit more, right, because 6 goes into 18, but at this point, I'll just go ask the calculator to finish it for me, and I'm getting 1,140. So that's where that number is coming from. It's coming from the 20C3 in the bottom. And then, by the way, the numerator in this case was just a 1. It's often just a 1 in a lot of these problems. And the reason for that is that there's only one way for us to get that particular combination they wanted, which was like beef, pepperoni, tomatoes, or whatever it was. There's only one way to get that combination. So that's why the numerator is just a 1. Now, I want to say something about this because some of you might be thinking, yeah, 1 second, John. I want to make a point about something real quick. Some of you might be thinking, well, you know, yeah, there's only one possible way to get beef, pepperoni, tomatoes, but isn't there more than one way? Because you can have beef, pepperoni, tomatoes, pepperoni, beef, tomatoes, beef, tomatoes, pepperoni, right? You can mix them up, right? So in that case, if you decided to solve the problem like that, what would end up happening is your numerator would be a 6 because there are 6 ways to mix those three ingredients or toppings rather up. But then your denominator would not be a combination. If you're choosing to say, actually, I do want order to matter, then what ends up happening is your denominator would not be a combination anymore. It would be a permutation. And if I do 20p3, so 20 instead of combination, but a p, I get 6,840. But that actually simplifies to the exact same thing. So if any of you guys are clever and thinking about like, oh, but don't, you know, I can reorder the topping. So how does that come out? You know, is it a different problem? Well, actually, the answer is no. It's the same problem if you decide to make the order matter in this kind of problem, right? The other kinds, not so much, right? Not so simple, but I just wanted to point that out in case that was like bugging anybody. Okay, John, what's your question?
Okay, so like during the exam, when we're doing problems with the exclamation points, I know like on yours you're like doing them yourself, but if we use our calculator, like how are we, is there any way that we can do that, like using our calculator for those?
Wait, are you asking if you can use a calculator on the exam?
Yeah, but like I'm just saying, like on some of them with the exclamation points, like I know on Hawks, like there would be some that would be like pretty lengthy, and like when I like go to divide it on my calculator, like it'll like read out like some crazy number. So like sometimes it won't like give me the answer, I guess.
Oh, well, it might depend. Are you talking about the ones like from 7.2 where they had like a
Mhm.
fraction of like combination over permutation?
Yeah, there's I think there's some on 7.2 and like maybe a few on 7.3.
Okay, I think I know what you're talking about. Let me go back to the lesson builder and let's see. I think this was this 7.2. Maybe like a problem like this, or actually more like this maybe.
Right.
So yeah, okay. So the trick to this is if you've got a scientific calculator, the trick to being able to do this all at once is to wrap the top and the bottom in parentheses, because otherwise your calculator might get confused about what order it's supposed to be dividing things in. So so let me write this down and then we'll come to my camera here. 7p6 over 7c6. Okay. Okay. Where's my little button? There we go. Okay. All right, so we've got 7p6 over 7c6. So the way I would do it on my calculator, oh goodness, where is that light even coming from? The way I would do it on my calculator is I would do 7 and then, no, sorry, parentheses, 7 and then the p thing and then 6, close parentheses. So I don't know if you can find that. And then divided by, and then again, open parentheses and say 7 and then C6, and then close parentheses. So wrapping the numerator and the denominator in parentheses, I think are going to be super important here. And it gives me, oh gosh, I don't know why the glare is so bad. I have no idea where the light is coming from. Anyways, it's giving me the 720 is the right answer there for that problem. Now, if you're coming across a problem where the number is just huge, oh, your calculator might be giving it to you in scientific notation. Is it doing that? Like, does it say like a number and then e to the 10 to the third?
Yeah, yeah, that's what I'm talking about.
Okay, yeah. That is if you're not
So,
familiar with scientific notation, then that would seem kind of wild.
okay.
That is going to be something that you can, it's a mode in your calculator. Without honestly, without having your calculator here in front of me and being able to like punch a bunch of buttons on it, I don't know how to fix that. What I would do is, let's see, you're gonna have to do some poking around on Google. I would Google the name of your calculator, and then what do you want to say? You want to say maybe like decimal format answers, because it's giving you scientific notation format, but you want just a normal decimal format. It's not, I've done it on, a few calculators. It's a matter of like choosing the right mode. You have one of those calculators that lets you pick different modes, I think.
Right.
Yeah,
Like
it's
mine even has like the like it has the NPR and then there's another one for NCR. Like I can press that, but like it has like a shift button and it just doesn't work. So I don't know. I'll have to look up and just find out. I guess I have to be in that mode like you're talking about, like some type of different format.
Yep. That's what it is. It's outputting the answer in scientific mode and in scientific notation, and there is a way to fix that. So if you or anyone else in here or watching this video later has a calculator like that, then you can come to the test early, and I'll be there, and we can get everyone's calculator sorted out.
Okay.
Yep.
All right. Thank you.
Yep. Okay, any other questions? All right. Let's see, Friday, I don't expect the weather to have any impact on our ability to take the exam on Friday. So I will see you all there in room, what is it, 357 at 10 a.m. in Ayers Hall for exam 3. All right. You guys are good to go. See you later.